Hello all, I am Naganiraj and I am from the Department of AML. Today we will be dealing with the topic implementation of hidden Markov model. Firstly, we will be importing all the necessary packages. We will be starting with importing NumPy as NP, and next we will be initializing all the necessary matrix like transition matrix, initial probabilities, observed sequence and emission matrix. These cells initialize all the data required for the hidden Markov model. Firstly, the transition matrix. This represents the probability of moving from one weather state to another weather state. If today it is sunny, tomorrow is sunny with the probability of 0.7, and if today is rainy, if today is sunny, tomorrow is rainy with the probability of 0.3. Coming to the initial probabilities, represents the probability of starting in each stage. P of sunny will be 0.5 and P of rainy would be 0.5. Both states are equally likely initially. Next, the observation sequence. These are the observations received from the environment. 0 is observation A and 1 is considered to be observation B. Emission matrix. Coming to the emission matrix, represents the probability of an observation being produced from a state. For sunny it is 0.1 and in observation 0 and 0.9 in observation 1. Rainy it is 0.8 in observation 0 and 0.2 in observation 1. Next, coming to the next cell, this creates the alpha matrix and initializes first step. The forward algorithm uses the alpha matrix and alpha tj, probability of observing the sequence up to time t and ending in state j. There are totally 6 observations and 2 hidden states. For first observation, it would be initial probabilities alpha 0, initial probabilities into emission matrix, observed sequence of 0. And coming to next cell, forward algorithm recursion. These two cells represents the forward algorithm recursion. This is the core forward algorithm. Alpha tj equal to b of o into t summation alpha t minus 1 in of I aij. A of j represents the forward probability, b of j represents the emission probability, and aij is the transition probability. And this will be calculating. The algorithm repeats this for every time step and every state, and finally it computes the probability of observation sequence, and the observation sequence turned out to be 0.018906881625 for our model. After processing all the observations, alpha minus 1 to 1 is to contains probabilities of ending in each stage. Total probability will be around 0.036 plus 0.004. Determines the most likely state of each state. This determines the most likely state of each of the state. And finally we'll be calculating the most likely sequence of weather state is sunny, 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 rainy, rainy and sunny. These are the most likely sequence of weather state for model. Thank you.